Hello students, in this video I am going to explain you some basic concepts of chemistry which is there for standard 11th. Okay. First things I am going to explain in this is law of chemical combination. Okay. So first law is what? Law of conservation of mass. Okay. As you can read the statement, it was given by Anthony Lavoisier in the year 1789. Okay. This date is not important. Okay. This law states that matter can neither be created nor be destroyed. Okay, or we can say in a chemical reaction, the mass of reactant is equal to the mass of product. This is called as law of conservation of mass. The second law is a law of definite proportion, or also called as law of constant composition. Okay, this law was proposed by Louis Proust in the year 1799. Okay, this law states that a chemical compound always consists of same element combined together in the same ratio, irrespective of the method of preparations or the source from where it is taken. For example, if you see H2O, okay, what is the ratio of mass of hydrogen to the mass of oxygen? Mass of hydrogen to the mass of oxygen. Okay, as the atomic mass of hydrogen is 1, so 2 into 1 by atomic mass of oxygen is 16. So we are getting 1 is to 8. Okay, so this ratio of hydrogen and oxygen will be fixed. Okay, the ratio of masses of hydrogen and oxygen will be fixed irrespective of the method of preparations or the source from where it is taken. Okay, next law is there, law of multiple proportions proposed by Dalton in the year 1803. This law states that when two elements combine to form two or more compounds, then the different masses of one element which combine with the fixed masses of other bear a simple ratio of one another. Just remember the statement, then ask. Okay. Next law is there, Gay-Lussac's law. Okay, so according to this law, when gases combine or are produced in a chemical reaction, they do so in a simple ratio by volume, provided all the gases are at same temperature and pressure. For example, you can see hydrogen and chlorine combine to form hydrogen chloride gas. So here it is one volume. This is also one volume. This is two volumes. So here the ratio of reactants and product is what? 1 is to 1 is to 2. Okay. So whenever they are reacting, they will react in a simple ratio. Okay, other example you can see nitrogen combined with hydrogen. Okay, to gives you what? Ammonia, NH3. Okay, so this is nitrogen 1 volume, hydrogen 3 volume, and ammonia 2 volumes. This is in the simple whole ratio. Okay. Next law is there, Avogadro's law. Okay, it was given by Avogadro in the year 1811. According to this law, equal volume of gases at same temperature and pressure should contain equal number of molecules. Okay, so this law is also very important. Or we can say statement is there. Volume of a gas is directly proportional to the number of moles. Volume of a gas is directly proportional to the number of moles. Okay. Next, Dalton atomic theory, which is very important. They may ask you, okay, according to what are the postulates of Dalton atomic theory? They may ask. See, all the substances are made up of tiny individual particles called as atoms. Okay, first postulates. Second, atoms of same elements are identical in shape, size, mass, and other properties. Okay, next, atoms of different elements are different in all respects. Next, atom is the smallest unit that takes part in chemical reactions. Okay, and atoms combine with each other in simple whole number ratio to form the compound atoms called molecules. And atoms next, atom cannot be created, divided, or destroyed during any chemical or physical changes. Okay, so actually most of the concepts of postulates of Dalton failed after the discovery of isotopes. What are isotopes? Isotopes are the atoms of same element, okay, having same atomic number, okay, but different mass number. For example, hydrogen is having 3 isotopes, atomic number 111 and mass number 123. As Dalton had told that atoms of same element are identical in all respects. But here isotopes are the elements, or these are the atoms of same element having different mass number. Okay, similarly, Dalton had told that the atoms of different elements are different in properties, But after the discovery of isobars, okay, isobars are what? These are the atoms of different element having same mass number. Okay, having same mass number. So these concepts failed that atoms of different elements are identical in all respects, right? Because you can see in the isobars, the mass number of different atoms are same. Okay, so okay, you should be knowing what is atoms and molecules. Actually, when we talk about atoms, atom is the smallest particle of the matter which does not exist independently. Okay, and what is a molecule? Molecule is a group of atoms. Okay, which exist independently. Okay, so here you can see the smallest particle of an element which may or may not exist. Okay, which may or may not have independent existence is called atom. While the smallest particle of the substance which is capable of independent existence is a molecule. Okay, so molecules are classified as homoatomic, heteroatomic. Okay, when you talk about homoatomic means what? Made up of same type of atoms. Okay, made up of the atoms of same element. Okay, and heteroatomics are the atoms of the made up of the atoms of the different elements. Homoatomic like a Cl2, O2. Okay, this chlorine is made up of two atoms of chlorine. Okay, oxygen gas is made up of water, two atoms of oxygen. Okay, heteroatomic, when we talk about heteroatomic means what? NH3. Okay, NH3 is a molecule, okay, which is made up of nitrogen atom and hydrogen atoms. Hydrogen atom, right? Carbon dioxide molecule. It is made up of carbon atom and oxygen atom. Similarly, the molecules are also classified based on the number of atoms. If the number of atoms is 2, it is called as diatomic. If the example Cl2, O2, if the number of atoms is 3, it is triatomic. If number of atoms is more than 4, it is a polyatomic. Okay, like a P4. Okay, set. Okay. Next, the concept is their atomic mass unit. Okay, very important atomic mass unit. See, so many students get confused in atomic mass unit and atomic masses. Okay, see here, one atomic mass unit is defined as the mass exactly equal to the 1/12th of the mass of one carbon 12 atom. Okay, one mu is actually equal to what? 1.66. Okay, you can remember up to here into 10 power minus 24 gram. Okay, so today mu has been replaced by u, okay, which is known as unified mass. Okay, so here atomic mass actually is what? Mass of one atom by 1/12th of the mass of carbon 12 atom. The atomic mass of an element is defined as the average relative mass of an atom of an element as compared to the mass of an atom of carbon 12. Okay, taken as 12. Okay, gram atomic mass. Okay, if the atomic mass is expressed in gram, it is called as gram atomic mass. So the quantity of an element whose mass is in grams is numerically equal to the atomic mass actually. Okay, for example, if I say, okay, sodium atom, okay, its atomic mass is what? 23 gram, 23 U. Okay, if you atomic mass is what? 23 U. Okay, and gram atomic mass is what? Gram atomic mass. Okay, of sodium, we can write as 23 gram. Okay, so if when you express this atomic mass in gram, it is called as gram atomic mass. So the quantity of an element whose mass is in gram is numerically equal to the atomic mass. Okay, in simple terms, atomic mass of an element expressed in grams is the gram atomic mass. Okay, so for example, here atomic mass of oxygen is 16 AMU. Therefore, the gram atomic mass of oxygen is what? 16 gram. Okay. Next, we should know about the molecular mass. What do you mean by molecular mass? Okay, molecular mass of a substance is defined as, okay, molecular mass also very important. Okay, it is defined as the average relative masses of its molecule as compared to the mass of one atom of carbon 12 taken as 12. It expresses as to how many times the molecule of substance is heavier than 1/12th of the mass of another atom of carbon. Okay, so for example, a molecule of carbon dioxide is 44 times heavier than the 1/12th of the mass of an atom of carbon. Therefore, the molecular mass of CO2 is 44. And how this is important, how we are finding the molecular mass, and it is obtained by adding the atomic masses of all the atoms present in the molecule. For example, when you see Carbon dioxide, what is the atomic mass of carbon? 12. Okay, so one atom is there, so 1 into 12 plus what is the atomic mass of oxygen? 16. So 16 into 2. So 12 plus 32, that is equal to 44 U. Okay, this is the molecular mass. Okay, when the molecular mass is expressed in gram, it is called as what? A gram molecular mass. Okay, so same thing here. If what is the gram molecular mass? So here 44 U, we can write it as 44 gram. The method is same. Okay, now I'm going to discuss very important concepts. Okay, mole concepts. So before that, just read here: a quantity of substance whose mass m is numerically equal to the molecular mass is called as gram molecular mass. In simple terms, a molecular mass of substance expressed in grams is called as gram molecular mass. Example: the molecular mass of oxygen is 32 AMU, right? So therefore, how it is 32 AMU? Because 16 to 2, that is equal to 32 AMU. So gram molecular mass of oxygen is what? 32 gram. Okay. Next concept is there, formula mass. Okay, formula mass is generally we are considering for ionic compounds. Okay, sum of atomic masses of elements present in one molecule, one formula unit of a compound. Okay, like NaCl. NaCl is a what ionic compound, right? So what is the formula mass? So see, atomic mass, it is the same way. How we are finding it is the same way how we are finding the molecular mass. So sodium atomic mass is 23, chlorine is 35.5. So 35.5. Okay, so water 58.5 U. Okay, so you can see here formula mass is the sum of atomic masses for the elements present in one formula unit of the compound. It is used for ionic compounds mainly. Okay, now we'll focus on the mole concepts. Okay, so mole concepts. Okay, mole can be defined in three ways. Okay, generally, see, 1 mole of a substance is equal to 6.022 into 10 to the power 23. It may be atoms, it may be ions, it may be molecules. Am I clear? Okay, 1 mole of substance is equal to this much. Yeah, 1 mole is actually a number. If I say 1 dozen egg, how many egg? 12 egg. 1 dozen pen, how many pens? 12 pen. Similarly, if I say 1 mole of sodium atom is equal to how many atoms of sodium? That is equal to 6.022 into 10 to the power 23 atoms of sodium. If I say 1 mole of oxygen, so oxygen gas will contain what? Molecules, right? So that is equal to 1 mole of oxygen gas is equal to 6.022 into 10 to the power 23 molecules of oxygen. This number is fixed. Okay, this is called as Avogadro's number. Avogadro's number. Okay, so 1 mole, you can see mole is defined as the amount of substance which contains the same number of chemical units, atoms, molecules, or ions, or electrons, as there are exactly in carbon, exactly in 12 grams of pure carbon 12. Okay, so this is the definition, or simply you can write 1 mole represents a collection of 6.022 into 10 power 23. Okay, chemical units. Okay, the mass of 1 mole of a substance is the in grams is called as molar mass. See, 1 mole is also equal to 1 mole is also equal to gram atomic mass. Gram atomic mass. Okay, or gram molecular mass. Gram molecular mass. For example, if I say, okay, 1 mole of sodium atom is equal to how much gram? Okay, 1 mole of sodium is equal to dash gram. So what is atomic mass of sodium? 23. So that is 23 gram. Am I clear? If I say 1 mole of oxygen gas is equal to dash gram. So oxygen gas, so what is the molecular weight of oxygen? Okay, O2. So 16 into 2, that is equal to 32. Yes or no? So 32 gram. Similarly, if I say 1 mole of water, okay, H2O is equal to dash gram. So what is the molecular weight of water? Okay, water molecular weight. Hydrogen is 1 into 2. Okay, atomic mass of hydrogen is 1 into 2. Okay, 2 atoms are there. Similarly, oxygen is 16. So 2 plus 16 is what? 18. So it is what? 18 gram. Am I clear? So mole can be defined in the terms of gram. Okay. Third way to define the mole, 1 mole of a gas. 1 mole of a gas is equal to 22.4 liter. Okay, 22.4 liter. Okay, this is at STP, standard temperature and pressure. Okay, so three formulas you should remember. Okay, so to find the number of moles, okay, how we find the number of moles? Number of moles, mole is generally represented as N. Okay, first is what? Given weight by molecular weight. Okay, first formula is what? Given weight by molecular weight. Okay, so we can write N is equal to given weight small w by molecular weight. Okay, weight by molecular weight. This is the first formula to find the number of moles. Okay, second formula. Okay, number of moles. Okay, is equal to what? Given number of particle. Given number of particle by Avogadro number. Upon Avogadro number. So we can write a small n is equal to given number of particle as n and Avogadro number as Na. Okay, so this way you can remember the second formula. Okay, small n is what? Mole. Capital N is what? Given number of particle, and Na is what? Avogadro number. And third formula, given volume by 22.4 liter. Okay, third formula you can remember. Number of moles is equal to what? Given volume by 22.4. So we can write N is equal to V by 22.4. Okay. For example, you see here, suppose if they ask 11.2 liter of chlorine gas is equal to dash mole. So which formula will apply? Okay, this formula. Number of mole is what? Given volume. How much is the given volume? 11.2 by okay 22.4. So this decimal will get cancelled. This exactly cancelled by 2 times. So 1 by 2 means 0.5 mole. 0.5 mole. If they ask you that 12.044 okay atom of carbon is equal to dash mole, which formula will apply? This formula, second one. Okay, number of mole is equal to given number of particle by Avogadro number. Okay, so the number of atom of carbon is what? 12. The question is there 12.044 into 10 to the power suppose 23 atom of carbon is equal to dash mole. Okay, so given number of particle n by Na. So how much is the given particle? 12.044 into 10 to the power 23 by Avogadro number is what? 6.022 into 10 power 23. So this get cancelled. This is exactly cancelled by 2 times. Okay, so 2 mole. Okay, one more questions I am taking. If they ask you that 90 gram of water, 90 gram of water is equal to dash mole. So what is the formula? Now weight is given. Okay, this formula will apply. N is equal to what? Given weight by molecular weight. What is the weight given? 90 gram. What is the molecular weight of water? 18. So 18 1 18 5. So 5 mole. Am I clear? This in this way we can solve the numericals of mole using these three formulas. Okay, very important. Okay, next we talk about the percentage composition. Okay, percentage composition. Okay, see the mass percentage of each constituent element present in any compound is called as its percentage composition. Okay, mass percentage of an element, how we find the mass of element in one molecule of the compound by molecular mass of the compound into 100. For example, in water, okay, see here an example I'm just discussing. In water, H2O. Okay, what is the percentage of hydrogen and what is the percentage of oxygen? Okay, so percentage of hydrogen, if you want percentage of hydrogen is what? Okay, what is that mass of hydrogen? Okay, atomic mass is 1. So 1 into 2 by molecular weight of the compound. Okay, what is that? 18 into 100. So 2 1 ja 2 9 ja 100 by 9. So it is 1.11%. Okay, similarly, if I ask a percentage of oxygen, how much oxygen is what? 16 gram. Okay, so 16 by 18 into 100. Okay, so if you cancel 8 2 ja, this is 9 2 ja. Okay, so 800 by 9. You solve this. Okay, so we'll get that percentage of 88.8 you will get something on that. Okay, so am I clear? Next, chemical equations. Okay, so shorthand representation of a chemical change in the terms of symbols formula of these substances involved in the reaction is called as chemical equations. Okay, for example, burning of magnesium. Okay, magnesium burns with oxygen, gives you what? Magnesium oxide. The substances which are combined is called as reactant, and the substance, new substance formed is called as what? Product. Am I clear? The substances that react among themselves to bring out the chemical changes are called as reactants, whereas the substances that are produced as a result of chemical change are called as products. One concept is there, limiting reagent, that you should know. Okay, so the reactants which gets consumed first or limits the amount of product is known as limiting reagent. Okay, very important concepts. Okay. Okay, next I'm going to explain you about the reactions in a solutions. Okay, when we talk about solutions, what are the two components of solution? Solution mainly contains water, solute and solvent. Am I clear? For example, if you dissolve 2 gram of glucose, okay, or little bit 10 gram of glucose in a 1000 ml of water, 1000 ml of or 1000 gram of water, suppose 1000 gram of water. Okay, H2O. Okay, the component which is present in a smaller quantity is water, solute, which is present in larger quantity is water, solvent. Am I clear? So I'm using some sign convention here. Weight of solute, I'm using a small w, for a solvent capital W. Okay, I'm using molecular weight for a solute is what? Capital W. Sorry, 1 second. Okay, molecular weight of solute I'm using as a small m. Okay, and weight as small w. Molecular weight of solute here. Okay, weight of solute I'm using a small w and molecular weight is a small m. Okay, and weight of solvent I'm using capital W and molecular weight is capital M. Am I clear? Okay, so when we talk about mass percentage, okay, so it is the mass of the solute in gram per 100 grams of the solution. Mass percentage is nothing but a mass of solute into 100 by mass of solution. What is mass percentage? Mass of solute by mass of solution into 100. So we can write a mass percentage of solute is, mass of solute is what? A small w by mass of solution, a small w by small w plus capital W into 100. Am I clear? One more, I'm using volume. Okay, volume of solute small v and solvent capital V. Okay, so volume percentage. Next, we talk about volume percentage. Okay, so it is the number of units of volume of the solute per 100 units of the volume of solution. For example, volume percentage of solute is what? Volume of solute by volume of solution into 100. Okay, so how will you find the volume of solute is what? A small v. Okay, here volume of solution small v plus capital V into 100. Am I clear? In this way, we can find out the volume percentage. Next, you should know about the molarity. Okay, molarity is nothing but the number of moles of solute. Okay, defined as the number of moles of solute dissolved per liter of the solution. Okay, so molarity is what? Number of moles of solute. Okay, by volume of solution. Volume of solution in liter. Okay, this is the volume of solution in liter. How we find out the number of moles of solute? Weight of solute by molecular weight of solute by volume of solution in liter. Okay, but in numericals, okay, they may give you the volume in milliliter. So to convert the milliliter into liter, we know that 1000 milliliter is equal to what? 1 liter. Yes or no? So 1 ml is equal to 1 by 1000. So you have to convert, you have to multiply by 1 by 1000. So 1000 will go to the numerator. So final formulas of molarity will get a weight of solute by molecular weight of solute into, if the volume is given in milliliter, so by 1000 if you are multiplying, 1000 will go to the numerator. SI unit will be water, mole per liter. SI unit will be water, mole per liter. Okay, molarity equations you see here. To calculate the volume of a definite solution required to prepare a solution of other molarity, following equations are used. M1 V1 is equal to M2 V2. What is M1? Initial molarity. M2 is the molarity of new solution. V1 is the initial volume. V2 is the volume of the new solutions. Okay, next concept is there. Molality, very important. molality is defined as the number of moles of solute dissolved per per 1000 gram of solvent or 1 kg of solvent. Okay, so molality is nothing but a number of moles of solute by mass of solvent in kg. We can write a mass of solvent in kg. Okay, how do we find the number of moles of solute? A number of moles of solute we find as a given weight by molecular weight, right? So number of moles of solute is what? Given weight by molecular weight. Mass of solvent is capital W in kg. Okay, so this is the formula: small w by small m into 1 by capital W in kg. Okay, if the mass is given in gram, so to convert the gram into kg, we have to multiply by 1 by 1000. So final formula we can write molality is equal to water given weight of solute by molecular weight of solute by mass of solvent in gram means 1000 will come to the numerator. Am I clear? So SI unit will be water mole per kg. Okay, SI unit is water mole per kg. Mole per kg. See, molality is a better way of expressing the concentration. Why? Because it is dependent on the mass of the solvent, right? And mass of the solvent does not change with temperature. Whereas when we talk about the molality, okay, as the molality is depending upon what? Volume of solution, which changes with temperature. So when we compare with the molarity and molality, which is better way? Molality. Okay, second one. Molality is the better way of expressing the concentration. Okay. So next we talk about mole fraction. Okay, mole fraction is nothing but a number of moles of one component by the total number of moles of all the component present in the solution. Okay, for example, suppose there are two components, okay, solute and solvent. So mole fraction is generally represented as what? X. So mole fraction of a solute is nothing but moles of solute by moles of solute plus moles of solvent. Similarly, if they ask a mole fraction of solvent, it is nothing but the moles of solvent by moles of solute plus solvent. Okay, and the sum of mole fraction of all the component is equal to 1. So mole fraction of solute plus mole fraction of solvent is what? 1. Am I clear? Next we talk about the last concept is there, empirical and molecular formula, which is very, very important. They may ask you questions based on this. Okay, when we talk about empirical formula, okay, it is the simplest formula of a compound giving simplest whole number ratio of atoms present in one molecule. Okay, for example, C6H6. Okay, so an empirical formula of this is what? CH. Okay, the simplest formula CH. Okay, it is the simplest formula of a compound giving the simplest whole number ratio of atoms present in a one molecule. Example, CH is the empirical formula of benzene. Okay, what is a molecular formula? It is the actual formula of a compound showing the total number of atoms of constituent elements. Example, C6H6 is the molecular formula of benzene. So there is a relationship. Okay, molecular formula is what? Empirical formula. Okay, into n. So n is the simple whole number having values maybe 1, 2, 3, etc. and can be calculated as what? A molecular formula mass by empirical formula mass. Okay, so there is a relationship between empirical formula and molecular formula. Okay, n is equal to what? Empirical formula by n is equal to molecular mass by empirical formula mass. Okay, and the two formulas are related as what? Molecular formula is equal to n into empirical formula. Okay, in the next video we'll be doing some numericals based on these concepts. Okay, so if you like my this video, please share with your friends and don't forget to subscribe to the channel. Thank you.